Okay, now it works. So the main thing about a prototype is that its purpose is to be used for interaction of some kind, whereas a sketch is not necessarily something that a user or you as a designer are going to interact with in the way that you interact with the final product. So for that question, kind of just 2 points. If you describe a prototype and then at least compare it to a sketch in some way, or talk about the difference. So the second question, ask for an example or just a description of low fidelity and high fidelity prototypes. Anybody have an example of low fidelity? Yeah.
Like the paper prompts that we saw. Just giving an example of how it would afterwards.
Right. Okay. So that's a good example. Anybody have something different? Or yeah. Sketch. Yeah. So a sketch, yeah, definitely can be a low fidelity prototype if you're using it to show a user and have them interact with it. What about high fidelity? What do you guys put for high fidelity?
I'm on a team that has to develop a robot. The first one was for low fidelity, and I'd say the one right before the final one would be a higher fidelity prototype.
Okay. Yeah. So kind of the general idea that as you iterate and progress, the thing that you end up with will be higher fidelity. Whereas like if you're doing just a proof of concept or something, then that might be a low fidelity prototype. Anybody have anything different about prototype, high fidelity, low fidelity?
Instead of components, wall versus the new components.
Yeah, I mean, yeah, I could see that. If your overarching goal for the experience is something bigger, and you start at one place and end up at another. Okay, so how about the third question? A benefit and a drawback for writing code as part of a prototype. Anybody have a benefit?
Speed up development.
Okay, yeah.
There's like no limitations on what you want your prototype to do.
Right. Yeah. So you don't have any constraints. What about a drawback for writing code?
Maybe you waste some time.
Yeah. So it can be a double-edged sword on kind of everything. So it could be something that speeds things up. It could be something that slows something down. It could be a waste of time because you're going to throw it away. It could just be that the thing you're working on doesn't really require anything that special, and so you can just use off-the-shelf piece of software. So, okay, if you'll go ahead and just put a score on those and then pass them to that side, I'll pick them up. So last time we talked about prototypes. We talked a little bit about kind of just general prototyping concepts, the idea of having different fidelities of prototype. We talked a little bit about hardware prototypes as well as software prototypes. One thing that's kind of important with prototypes to really keep in mind is this idea of you have both like the full spectrum of things that your application or your system is going to do, and then you have kind of the depth, like the completeness of each of those aspects. And so with prototype, you may, only go to the surface level on some things, and then may go very deep on other things, or you may cover all of this. So today we're going to talk about some development methods and tools for developing user interfaces. And so for today we're going to talk mainly just about graphical user interfaces. So we're not going to talk about anything like natural language or gestures or anything that's not keyboard, mouse, or touchscreen kind of thing. And so we'll just kind of start with kind of something that's pretty important to remember, and that's the life of an interface itself. And so what you really got to think about is that you can't really completely remove yourself from the context that your system exists in. So the app you build or the system you build is going to run on some software runtime environment. It's going to run on some piece of hardware, and it's going to be located somewhere. And for some things, we don't have to worry a lot about knowing too much about that. Like if you write a web application or service, you can deploy it to any of the cloud providers kind of hosting things, and you may not even know what operating system, what data center, what architecture that's running on. And that's not always a problem. But in general, understanding the underlying operation is always helpful. It doesn't really ever hurt, and particularly for user experience, the implementation can matter a lot. So if it's something where you've got an interface where someone can draw with a stylus, you might really gain some insight if you understand the hardware acceleration that's happening with the digitizer in the tablet that they're using. And that may make or break your user experience. That may be the thing that sets you apart when you're building that product. And so while it's not always super important, you shouldn't brush it off as saying, we're at a high level and we can just kind of specify things in this abstract way and not worry about the lower level. So we're going to briefly talk about the lower level. And for graphical user interfaces, it comes down to two things, and it's input and output. And the output being manipulating on and off states of a bunch of tiny little lights that make up the screen in an image. And then the input being sensing an electrical signal, whether that's a mouse moving that's being converted to that, or that's a key being pressed, or a touch screen being swiped on. And this is the same for other modalities. There's always this really low-level place you can go to, where it's literally turning things on and off, arranging pixels, manipulating things like audio buffers and pushing them through with the right timing to make things work. Now, obviously, if we had to work at that level, that would be problematic. If everyone had to start at that level, we would not be able to build a lot of the things that we're interested in building. And so throughout the history of computing and HCI and the graphical user interface, a lot of layers have been put on top of these basic things. And that's what we'd expect, right? Somebody solves a problem once, they make a nice abstraction. That's what we typically like as computer scientists and people who program. It's pivotal to engineering. We solve a problem and then we reuse that solution as much as we can. And so when we think about something like drawing, right? It's not usually our focus, for example, to paint each pixel or to look at low-level signals. But here's an example of something where this might actually make its way up to you with your user interacting with the screen. Something as simple as anti-aliasing, right? Okay, so this is pretty automatic. It's there in a lot of cases. But every now and then you might run into a situation where you're getting a weird bug or there's some odd artifact of the experience, and you'll end up down at this level sometimes. And it may just be that it's happening on some devices and not all devices. But you've got to be aware kind of the the fact that this full stack is there, and then you may have to go up and down it at times. So as we've moved away kind of from just like pixel manipulation, kind of one of the first things that's done in an operating system or in the graphics component of an operating system or of just dedicated hardware is to provide primitives and abstractions. So we don't want to have to write our own algorithms and methods for drawing a line or a rectangle or even putting an image on the screen. And so those things kind of come to us with the systems that we work with. I think really there are very few places, maybe in a graphics course, maybe if you're doing something that's focused on drawing or art kind of applications, you would actually look at this level of primitive to look at things like how are these shapes being drawn, or how something like an audio file is being played. But in general, we expect to be able to use some high-level way of asking the system to do that. Pretty much any system we use. And so that's kind of just something that's taken care of. So the way that it's developed over time is basically you have something like a windowing system if you're just on a graphical user interface, and it's managing what's going on the screen, whereas your software is maybe specifying geometry. In most cases, we're not even that low level. And we expect that this system is going to tell us when something relevant to us happens, when a key is pressed that we care about, when a network message comes in that matters to us, when the orientation of the device changes, anything that we are interested in. We expect that to come from the system. So kind of the next level, and this is the level that we typically work at today if we're doing something that's considered HCI or considered designing a system or an interface for someone. We're working at a level that has constraints that are specific to maybe an operating system. So if you think about mobile operating systems like iOS and Android, they each have their own set of SDKs and APIs that are provided and ways of doing things. And so we don't even have to worry, like if we want a toggle switch, right, in one of these operating systems, we don't have to specify we're going to draw a circle and then an ellipse and then this, and when you click it, it's going to move this back and forth. We can just specify we want a toggle, and that's going to come with the system. On the other hand, we have some things that are specific to runtimes. They're not rooted in operating systems necessarily. So when you see cross-platform solutions, a lot of times historically they've been things like Java, for example. Java is implemented, the virtual machine that runs it is implemented on a number of platforms. And so as long as you can produce bytecode that will run on that standardized virtual machine, then it's going to run on any of those platforms and it should look the same. Also saw this with Flash, which thankfully is almost dead. And then we also see things that are not really, so these, I should say, you have to have the thing that, in Java's case, Sun and now Oracle develops the Java virtual machine, and they give it to you. You need that to run a Java application. You need the Flash plugin to run Flash applications. And that's something that people build. On the other hand, you can go down this route, which is what we see with web technologies, which is to have a standard. And so as long as a platform implements to that standard, things should look more or less the same and should behave more or less the same. So like in the case of the web, you've got a couple of different engines rendering, HTML and CSS. And for the most part, for the basic things at least, they look the same. And that's just based on standards. And so whoever's implementing a browser or something that's going to display this is trying to meet that standard. So shifting more to designing interfaces, right? So it's useful to be able to design an interface that we can interact with without having to think even as low down as like the operating system or the SDK that you're using. And this historically was meant for people who were purely designers, right? They just cared about the way something looked. They didn't really have an interest in programming or coding. And so they were really, essentially, we were developing software for people to design the aesthetic look of other software. And so it's always pretty much the big focus is on interface layout, specifically how components are placed on a screen, and especially when things change. And the idea here for using an interface design tool is that, you know, if you can directly manipulate the interface that you want to build, if you can just click on, you know, the control that you want, move it here, move it there, see it right in front of you, that's a lot more pleasant than coding in a lot of cases. And having that loop of, and this is not so much the case today, I should say, but especially in the early days, having to change your code, compile your code, run your code, see what it did. That alone can be a little bit tiring. And so it made sense to make these direct kind of manipulation design tools. And this is something that we saw like in the beginning when we're talking just about general cognitive HCI principles, right? Direct manipulation is something that works well for us. So we started to create these tools pretty early on. And then what we kind of came to focus on was the creation of what's usually referred to as widgets. And so the idea is that, you know, the system that you're working in will provide some primitive or elementary pieces. So maybe that's, you know, text, and maybe it's like a radio button and a checkbox and a text field. But then you can take those, combine them, set up their layout, and create this component that you could reuse potentially. And that's a theme that has carried on through today. So the big thing about, you know, like a runtime environment or just an interface design tool is that it has to support all of these kind of arbitrary widget designs that someone could create. So for example, if you think of, I think this is like Visual Basic or something, but anything like Microsoft, like .NET, C#, kind of, you know, you get in Visual Studio and you start dragging out some form controls and setting up things. You can create something that's, you know, never existed before, but the system's equipped to handle these primitive things and their relationships to each other. So initially, you know, we were focused on layout, but screens were not that large, really, and they weren't. There wasn't a wide variety of screen sizes compared to today. So we could really get away with kind of doing a really simple method of positioning things, of anchoring things, and kind of expecting that when our application is on the screen, it's probably the only application there. You're probably not having side-by-side things happening. And initially you would, you know, have one window. And so that, you know, that's what we would call a fixed layout. So if you were to change the screen size, if you were to, you know, change, in our case today, it's really common to change orientation of the screen, then a fixed layout would not necessarily look great. And I'll show you some examples of that later. What we kind of moved to as things began to change were these ideas of dynamic and relational constraints that we can put on the items that are on the screen. So I'm going to show you a video, well, part of this video. So this is Apple's HyperCard, is what the application was called. And it's pretty much an interface design tool. So I'll let them explain it for a couple minutes, and you'll kind of see, that it fits this description.
Joining us in the studio now is Bill Atkinson. Bill is an Apple Fellow, the creator of HyperCard, also the creator of QuickDraw and Mac Paint. Next to Bill is Dan Winkler. Dan is the senior engineer at Apple working on the HyperCard project. Gary?
Stuart, a HyperCard sounds like a hardware board you'd put into your computer
Right.
system, but this particular HyperCard comes in 4 floppy disks. Would you tell us what the HyperCard's all about, Bill?
Well, really simply put, HyperCard is a software erector set that lets non-programmers put together interactive information.
Show us how you actually do this, Bill.
You use cards that contain graphics and text and buttons. Here I've got a stack of cards, and I can press on this button, and it will take me to another card.
Okay, that button's particular function is get to the next card.
Right. You can have lots of buttons to do different things.
Okay.
Buttons can do things like dialing the phone and taking you to cards and lots of different
Whatever you
things.
tell it to do.
Yeah.
Okay.
The cards are grouped together into stacks that you put on a floppy disk and can share with somebody else. And you can organize it so that any card can jump to any other card.
Is this where you get that notion of hypertext built into the HyperCard system?
Yeah, it's kind of the freedom to organize the information according to how things are associated with each other, not just according to the next card in the list.
Right, okay.
The buttons, as I said, can do lots of things. Here's one that makes a noise and sounds. And you can have lots of different kinds of cards. The standard 3x5 card is a little weak metaphor, but you can include things like an expense report or maybe an appointment book, things like that. Lots of different kinds of things can be on cards. Even little interactions. Here's a little keyboard that you could click on, and it makes sounds and moves the note accordingly.
So you can do things within a card itself. A card is just not some
Right.
information.
What's real important is that cards contain both information and interaction.
Right.
That's sort of what's new here. One particular card that we use a lot is the home card, which serves as sort of a home base of leading out to all the other stacks of cards that I use frequently. For example, if I touch here on the home card, I can go to my address list. Here I've got cards that have names and addresses of people.
Now, can you make up your own stacks of cards then also?
Right.
Okay.
HyperCard comes with a set of stacks that you can use as they are, but also make your own.
Okay.
Some people they'll start by making small changes to the stacks, and then they'll actually make their own fresh ones.
And people have already developed quite a few stacks using HyperCard, haven't they? We've
Right.
heard about that.
There are several hundred on the public networks.
Okay, what other things can you do here, Bill?
So I might say, find Jim, and quickly get to a card containing that. Or
Okay,
I
wait,
could-
now that's a real new element you just introduced. You can actually just write a natural language phrase in here and ask HyperCard to do something for you.
find Jim.
Yeah.
It'll find it. I could go to a calendar, see a yearly calendar here, or touch on a particular day and go out to a weekly for
It's like
that.
it opens up the
Yeah, these are different stacks of information. Here I've got a stack that has my to-do list in it. And I could select something there, and then touch on the address icon, and that button will take me to the address stack and look up what I had just selected there. So I can have the information in these stacks tied together
That was
in
an
ways that
example, I
make
guess, of
sense.
following a hypertext link in that case, right?
Right. Only that was actually computed. It not only went there, but then did a search once it got
I see, yeah,
there.
Right.
I could have other stacks. Here, let's go back to the home. Here's a stack that contains more graphical information. Here I might say, find a horse, and get to a card that has a horse. Or I could branch around to other cards that had horses just by clicking on them. There's nothing real magic here.
Okay, so you went find horse, it pulled up all the horse cards, and you now have a horse card stack, is that it?
No,
No.
it's just shown me the next card that had the word horse in it.
Okay, well, that's what I meant.
I could say, show me, here's a button on this wheel. So if I touch on that, it's going to other wheels.
Oh, my goodness.
So these buttons or links can be used to express thematic threads running through information. Here, touch on a hat to get to things that have hats. And this way you can organize information in multiple ways. You can also scan through images rather quickly to just show me what's there, even if you don't know what you're looking for.
Dan, you were involved in the HyperTalk part of HyperCard, which is, I guess, the highest level here. Could you explain that a little bit?
HyperTalk is the language that tells the buttons what to do. When you look inside a button, you can see its script, which is its brains. This message box here, where we've been typing commands like find, can do a lot more. It can do calculations there. You can, it knows about the value of pi, it knows all the math functions, it knows what the date is or what the long date is. Oops. The long.
It's still
Nobody stopped typing.
Or you can give it little commands like go to next card, like that, and it will. And if you look inside one of these little buttons, you'll see that its brains actually say go to next card. That's how that button knows how to do
That's
what
the
it does.
script for that button.
This is how a customer or user would actually program the buttons themselves.
That's right. Like, let's make a new button. For example, let's go back to the first card here. Supposing we wanted this eye to tie in some other place, you could take the button tool, stretch out a button here, and say link that to, say find an eye, and say link it to this card. That's all it takes to make a new link between that eye and that
I see.
Another eyes.
so that you can go there. To do that much doesn't require any knowledge of scripting, but once you learn about scripting, you can progress to modifying buttons like that. If we look inside this button, we'll see that what link to really did was it wrote a little script for us.
Okay, which is your little program telling the button what to do.
Right. And now you can go in by hand and modify that. For example, we could add a visual effect. We could say visual effect dissolve, for example. And now, that very same button, when you touch on it, will dissolve to that eye.
All right, very nice. So, as you'll see, we have not come that far from HyperCard to the modern interface design tools. But you kind of saw all the ideas there, right? It's trying to simplify this process of building an interface. So the idea that we can drag boxes around things, and then we can kind of choose, it's going to link to this, and then if we really care a lot, we can actually write some code to help it do what we want it to do. So since, I think that was like 1987 or something, I'm not sure, I have to look. But since then, things have gotten a little bit out of control. So we have a ton of different devices that people expect to use for everything. Screen space has just kind of gotten a lot larger in the case of our laptops or tablets or desktops, and so that alone kind of disrupts the basic layout ideas that existed early on, because when somebody pulls something up on a 4K monitor, you kind of need to flow things differently than when they're looking at it on this projector. So we had to come up with different ways of doing layouts to kind of deal with that. So edge anchoring is kind of a popular way of doing a constrained layout. So you'll see this pretty much in every modern UI design. And that's the idea that you can take elements and anchor them, kind of pin them to maybe the right side, the left side. And so if the width expands, that element's going to stretch with that. Or if it's just pinned to one side, it's going to stick to that side. And so you can also kind of do some different things in terms of having things that are usually called either like springs or spanners, kind of setting different priorities for how things will lay out when your device, when the area that you have changes. So there's another way of thinking about this. So that's kind of the very graphical, very much 2D plotting out things perspective. We have what's also called variable intrinsic size layouts. And so this is very popular in something like Java for its kind of default GUI system. And the idea is basically to make kind of this hierarchy of components, and you don't necessarily know what it's going to look like. And I'll tell you, as someone who had to use this, it's horrible. So things kind of put themselves where they fit algorithmically, and aesthetically, that is usually not what you want. So you spend a lot of time fighting that. I think one of the books I was reading for looking at interface design tools, actually said that this was one of the most bizarre systems or something. So it's not a great way to do it. It's a tree structure that logically makes sense from a programmatic standpoint, but visually it usually is not pleasing. So today we use a combination usually of the layout techniques of anchoring things either relative to each other or to the boundaries that actually contain the system. So we'll see. We're going to look at some actual modern interface design tools today. But what we'll see is that a lot of the focus, and this is changing, I should say, like within the past year or so, and definitely like every week, I think, that I look at this, it changes. What these tools are capable of doing easily. But for the most part, visual arrangement is achievable in these tools. But doing much more than linking to another visual arrangement can be difficult, and without coding, I should say. So event handling usually has to rely on programming if it's not something simple. And that's easy to understand why, because it's hard to envision every possible thing that can happen. So, I mean, programming is an abstraction already on something, and so trying to abstract it higher and higher doesn't always work well. So this is kind of something you can see, for example, it's been a couple of years since I've used Visual Studio, but I think this is probably still the case. Usually you drag out your components, you build your UI, and when you want to talk about what's going to happen when someone clicks that button, you click on it and it throws you to an auto-generated piece of code, and you write what happens when the button gets clicked, the event handler, usually. And that's a pretty common way of doing things across platforms, languages. So you see that some of them have visual things. So if you've ever used what used to be called Interface Builder, and now it's just integrated into Xcode for the Mac and for iOS, it has visual aspects of dragging components out and kind of anchoring them and laying them out how you'd like them. But it also has some visual ways of setting up events. So dragging little things, whenever this is clicked, it triggers this event. Yeah.
In Visual Basic, it's the same way. You just double click the button and you
Yeah.
code the event behind it.
Yeah, and so that's been a pretty strong way of doing things. And so you can somewhat get that to a visual level, but not for everything. So here are some problems that we run into. So usually we want to support more than one platform. So we can't always devote the resources to independently developing an iOS app and an Android app. That's doable for some people with larger applications and the resources to do it. But for a lot of us, it would be nice to be able to kind of write it in a way that it's going to work on as many platforms as possible. Another part of it is that the platforms do constantly change. And so at some point, if you don't actively maintain the system that you've built, it will stop to function in the way that you intended for it to function. If you're using kind of like native design for a specific platform. And I think I touched on this pretty strongly, but there is a lot of programming required to actually facilitate the interaction. It's still very difficult to build something with these design tools that really facilitates the kind of interaction that the end user is likely to have with the product. Okay, so you're probably just wondering, how do I build this app that I have to build for FedEx? And so the answer is probably with web stuff, but let's go ahead and talk about prototyping software anyways. So UI prototyping software. Some disclaimers before we get started. I have opinions about what works and what doesn't work. I'll share experiences with why I think certain things about them. but there are a lot of tools out there. There are more tools out there than I can actually go look at and research and understand and play with and tell you about. So it's very possible that I don't even know about the thing that is perfect for you and your project. So I'm going to talk about a couple of specific ones, but I really would encourage you to look around on your own and try them out and see what works for you and what doesn't. So a lot of products, capabilities are rapidly growing. And I should say, again, like a year or two ago, it wasn't the case that you could, add code to a lot of these and customize them in the way that you can now. But things are really changing rapidly in this area. So a lot of products. Included this link here. So this is probably one of the best up-to-date websites I've found that list a lot of the popular prototyping tools, and it kind of gives you, you can check these different features that you're interested in, and then it sorts them, in terms of different things like, how easy they are to learn, if they support mobile interaction, that kind of thing. So what I'll talk about first before we get into specific tools. This is a survey that's conducted annually of people who work or self-describe themselves as working in user interface design, user experience design. So you can go look at the results of this survey. This is kind of what I used to choose the couple that I chose to actually look at in any depth. So I think they asked 3,000 people maybe for this 2018 survey. What do they use for design? And the most popular application by far is Sketch. Sketch is an app, and it is only for Mac. And it costs money, and now it costs more money than it used to cost because it's like you have to license it and pay a monthly thing because that's how we do software now, and it's horrible. So we're not going to talk about Sketch. If you have Sketch and you want to use Sketch, good, use Sketch. But it's a really good tool, I should say, but I think there are plenty of other tools that are more accessible for us that we can really look at. So kind of coming in second, and probably the most rapidly growing in popularity, is Figma. And so it works on any platform. So it's got a web application that you can use. And it's also got native apps for Mac and Windows. And that's one of the ones that I've used, and I'll show you some details on. After that, we see like Photoshop. That shouldn't really count. So Adobe Experience Design is another one that is becoming really popular. And Experience Design is doing a good job of getting a lot of community-built plugins and add-ons. And so while most, I think, all of the ones that I talk about will allow plugins and add-ons, which involve coding, by the way. So coding is still important to actually make these things work. But Experience Design seems to be, really kind of the product of interest. So I should say Figma is free for a certain amount of designs, but as an academic user, so just with your .edu, if you register with that, you can access everything that they have for free with unlimited designs and team collaborations and stuff. So it's really good in that sense. Adobe Experience Design is free. You can, if you pay for Creative Cloud, or if you want to just buy the individual app Experience Design, you can do that, and it gives you, you can have multiple projects and things, but it does allow you to have one for free. And actually, Experience Design, all Adobe products, I think it's a 60% discount for education. You have to check and see what they're actually doing now, but I think that's what usually the case is. So then these kind of trail off. So now we move on to kind of, there are a lot of questions on this survey. I should say I just chose these two to show you, so you should go look at it later because it's kind of interesting. most popular prototyping tools. And so this immediately kind of makes you go, well, what is the difference between this design tool and the prototyping tool? So in recent history, these two things have been separate. People use tools to design the way that something would look, to lay out everything, and then if they wanted to make an interactive prototype, then they would export those designs over to a separate application that would allow you to do things like add, things that happen when you click on this element or do this or that. These are merging together now. And so that kind of makes this not so relevant. So InVision is the most popular, but InVision actually, and this is classic, and that's because now InVision is a merged kind of tool. They've kind of revamped it. I should say that InVision still doesn't allow you to design in it natively. So you've got to do your design somewhere else and bring it in for animation. And then so we see some of the same suspects here. Interestingly, you do see just basic web stuff, HTML, JavaScript showing up pretty high in terms of prototyping tools. Okay, so I'll go through an example, and I'm going to go through it on 3 different tools that I chose. Start with Figma, and I needed a project to do, so I created this, and we will use it for this class, for these tools, and then on Tuesday when we talk about web technologies, we will continue with this project. So my really basic project is a smart nightlight, because everything should be connected to the internet, even nightlights. So the idea is just a nightlight. It's got like a little light sensor on here, and it's got some RGB LEDs in here, so you can change the color of it, right? And it's Wi-Fi connected, as it should be. So that's the basic idea. Just kind of sketched that out. Also wrote out kind of just a bunch of ideas about what kind of features this thing could have. Basically, like, obviously you can set the color, but maybe you could set like a schedule for it to auto come on and turn off or something. Obviously, you could see the status of it on an app, and you can do this all remotely because it's connected to the internet. Maybe you could set up something where it's measuring the light levels so it could adapt to that ambient light. And maybe you could even integrate like your Twitter notifications into the nightlight, because why not? It's already connected. So really basic level, just writing out some ideas. And then this is a sketch, not sketch, just of 3 basic panels and kind of the things I wanted to happen on them, which I then turned into a wonderful sketch here of a basic home panel, and a big thing here would be like a color picker. You can just scroll over, pick the color, you can slide the intensity up and down, maybe have some favorite presets, and then this is just some status message or whatever. Little configuration tab, maybe you want to schedule it, maybe you want to simulate the sunrise, because why not? And then you can link your Twitter and just everything to it. So, and then maybe some historical data would be good, because I've got this thing so it knows like how much energy it's using and when it's on, when it's off, and what's going on. So go ahead and provide some little visual of that. So this is the sketch, or these are the sketches that I went off of, and I'm trying to do this in Figma and Experience Design. I started this process at like 8 p.m. last night in the true spirit of what you might try to do. And I hope that you will learn from my mistakes. The third prototyping software that I looked at was Just in Mind, and when I say I looked at it, I didn't look at it. My fiance looked at it and graciously allowed me to screen record her building this prototype as well. And we'll see how it's. So she did a sketch too. Hers is simpler. So we'll see how that pans out. But we begin with Figma. So just some facts about Figma. I think I touched on most of these. It's got, all of these kind of have these concepts of like frames and components and libraries and constraints. The nice thing about Figma is that it's free for us. It supports teams and it supports collaboration actively. Like at the same time, you can work on it and look at it together. So that's kind of nice. And it does run cross-platform. So let's talk about my experience with Figma. So I started, my interface here, and I chose an iPhone 10. And I put the nice title up there. And so immediately, what I wanted to do was just run this to see what it's going to look like in the iPhone. And oh no, there's a notch there, but that's fine. It's not the end of the world. So then my next thought was like, okay, got this device. Obviously, like a user might rotate it, right? So what's going to happen? Because I was, wondering. I should say I hadn't used Figma before, so it was new to me, and I was, wanting to know more about the constraints because the big push with Figma is, it's very responsive and you can do these things and it should just work. Turns out there's no way from this to actually, rotate the device. So you have to go back and relaunch your preview with the device in landscape, and then you are presented with this. And so then you begin to Google things and try to find out how do I rotate it? Why isn't it doing this? Because in the design view, so over here, like when I would take this, you can drag it, right? And it would adjust perfectly with the constraints that I had, right? The thing stayed centered, stayed at the top. If you change it over here to a different device, it's all good, okay? Turns out, you actually, in most of these design tools, you have to design it specifically for a device, okay? So the idea would be that if you want an iPhone 10 portrait, you should make all of your screens in that. Then you should duplicate them and rotate them and fix them all for the other orientation, okay? So this is very, very, we're very much caring about a specific device in this case. And it's kind of frustrating to me because, and if anybody knows a way to make this not the case, please let me know. But I did spend like an hour and a half investigating this and until I found that little line in the documentation that said this is not possible. Because like in this design view, it's very responsive and it works very well. But just the way this is set up, when you actually run it, it doesn't. So what I should say is that you're expected to kind of copy paste this and adjust your design. But there are a lot of backlinking things. So like this is kind of like a master template, and you make instances of it. So somewhat your design propagates as you would expect, but not always. And the idea here, I think, is because this is a very focused visual tool, you really do want these beautiful device-specific layouts that come out of it. So for me, this was a challenge because I expected to design this thing, run it, and have this interactive, element like you would on a native device. Not the case. So next, I was like, all right, there's no color picker in iOS as a component or, just built in, and that's one of the reasons I chose something with a color picker because I wanted to show that, you're kind of just out of luck. Anyways, but I was like, well, I'll just get a toggle switch to turn the light on and off, right? Figma doesn't come with any libraries or anything like, the components that you would find in iOS or Android or Mac or whatever system you're working with. So you need to go get them. And so this Medium post really captures it. It says, every time you start a new Figma project, you have to go build your components library. So there's some investment required. So I Googled, and I found, okay, here's one that is free, allegedly. Has all the iOS elements. And I should say Apple and a lot of companies do provide design resources. These have just been converted into the formats for these various applications. So I clicked on the Figma one to download it, and then I had to register for an account, and so I did that. And then I uploaded it to the Figma thing, and it said no. So it actually imported it, and it showed it for a second, and then it said no. And I did this with a bunch of different file formats, and it just kept saying no, so finally I gave in, and I downloaded the Figma app to my computer, because like maybe that will help. And so then after a little bit of two-factor, yes, it works. So on the native app, you can import this thing, and guess what? If you switch back to the web thing, now it's on the web and it works there too. Why? Nobody knows. But now I had iOS elements, and so then I said I'm done with this, and that's all I did. So that's the extent, and this color picker is just an image that I drug in here. So now with Figma, you can do a lot of things, and so I'm obviously being very harsh on Figma right now. You should go look at the things that talented people have made with it. You can accomplish everything you want to accomplish with it, but you have to think about it in a way that was unfamiliar to me, and even with documentation was incredibly frustrating for what I had chosen to pursue. This happens sometimes. Anyways, so I have these. It's whatever. That slider doesn't actually slide. That's a whole other thing. So let's switch over to my fiance and what she's doing, and just in mind. It has all of these things, but it actually has a lot more things that come with it. You can actually use interactive like sliders and stuff. They slide, they work. Text input works like a keyboard. This is not the case in Figma. Problem with this is that it is a 30-day free trial, and then it limits some of your features after that unless you pay them. Although the free trial is just to an email, so I mean, you could just register another one probably. But they do maybe offer a 50% education discount if you're interested. And I bring this up because it did a lot better. So like, within 20 minutes, while I'm over here Googling things about Figma, she's already got her thing done, and has built a home screen with a slider that actually works, and then built the whole scheduling screen that she wanted, and then the stats screen there. So I should say though, before you get to experience design, color picker does not actually work here. So still a problem. So just in mind is pretty great in the sense of a lot of like native controls and inputs and sliders and things work. But if you have something like a color picker that doesn't exist in this system, you're not going to be able to do that unless you build it for this system by coding. So I'll talk about experience design a little bit. This morning, once I had a fresh take on life, I decided to try to make this an experience design, which I haven't used in a while. But same kind of stuff going on. Mac and Windows apps, you one free project, and the rest may be discounted. Same ideas here, same components, libraries, frames, all of that kind of thing happening. And so I was able within probably 10 or 15 minutes to make my basic app flow here. So was able to import the iOS components. Color picker is still not a thing, but these are clickable. They move from screen to screen, and you can preview it. It's not so like even the preview and experience design, you can't like rotate the device or anything. I should say that like the just in mind system, it does allow you to rotate the device and do interactive things. So it's a little bit better in that sense. The one kind of fine print here, I guess, for experience design is that they have so many plugins now that I'm certain you could do everything you wanted to do if you were to locate the correct plugins or write the plugins that you needed to do it. But let's just talk about, in general, kind of the struggles of these prototyping tools. So dynamic individual elements are problematic. In a lot of cases, something as simple as a toggle will require you to have a whole new screen with that toggle in a different state. Some of them are able to do specific elements and transitions, but most of them are not. Things like text input, only just in mind supported that out of the ones I looked at. I'm certain some others do, but it's not something that's there usually. So the other thing that I think is kind of a big for everyone who's working on a FedEx project is that most of these don't allow you to easily incorporate data and manipulate that data. So like sorting a list, filtering a list, doing things like that. It's very programmatic, and it's not facilitated with these tools unless you're using add-ons. I should say Experience Design has a pretty cool plugin that links up to Google Sheets, and you can use that as your data source, which is kind of cool. So these kinds of operations are not really served very well by the prototyping tools at this point. So really, my read of the situation is that the prototyping tools are rapidly approaching a place where they're going to be more interactive and dynamic. But right now, they're still very much rooted in the aesthetic value of things. Plugins and extensions are making this better. So why is the web the answer? That's what we're going to talk about on Tuesday. And I want to say up front, I'm totally not requiring you to look at web as an answer, but it's the most standardized thing we have for cross-platform. It's not going away, I would guess. There are a ton of resources on it. It can do more and more things. There are fewer and fewer reasons to build native applications for devices today. In fact, a lot of native applications today are simply web views wrapped in a native binary. And I think the investment is reasonable. Even if you know nothing about using CSS or HTML or JavaScript, I think you can learn it in a short amount of time, and I think it'll be worth it to you. And there's a lot of stuff you can use that other people have made. If you're willing to just do a little bit of coding, it can go a long way. And I will also say that probably all but like 2 or 3 projects from the past like 5 iterations of this course have ended up turning in a web solution for their projects. So next time we will talk about web technologies. We will continue the Nightlight app saga, and we will have a quiz on this stuff. It will be a very easy quiz though, so do not worry about it. Just kind of try to show up so you can write your name on it. And please, if you haven't taken the survey about making exam 2 a take-home exam, it's on Canvas, so please take that survey.
You haven't put that survey up on the grad student